Hello, welcome to Maths and Science Unpack. So far, we are looking at the major topic algebra. And since starting with algebra, we have looked at introduction where we talk generally about algebra. And then we dedicated another video to terminology. We looked at a number of things under terminology, but just a quick recap. We looked at what a variable is. We looked at a constant, a term, expression, a formula, equation, identity, and then we looked at what a coefficient is. When we say something is coefficient, what does it mean in algebra? Now, the major thing that we learned from this subtopic was trying to tell the difference between some of these, because some are very similar. For instance, the difference between an expression and an equation, the difference between a formula and an equation. We also looked at the difference between a term and an expression. Then the major one was trying to explain the difference between an equation and an identity. Okay, so you can check out some of the previous videos and get a detailed understanding about these terminologies. Then we started looking at the major topics in algebra, the major subtopics. The first one was substitution. So we had a video looking at substitution. And then today we want to look at expansion. And next one will be factorization. Now, these two go hand in hand because they are the direct opposite of each other. If you expand an expression, you get something that can be factorized back to the original expression that you expanded. So they work hand in hand. So it's usually helpful to consider these two topics hand in hand. So in this next subtopic, we will be looking at expansion. We will be looking at expansion. In algebra, when we say expansion, what actually do we mean? It sounds simple. It's actually very simple to carry out, but you need to understand some underlying principles. And that is what this lesson will be seeking to achieve. So let's go on and look at the topic expansion. But before that, I'll give a general introduction and explain how expansion and factorization relates. So let's go. So expansion. In algebra, what do we mean by expansion? In algebra, expansion in its simplest form is doing away with brackets, okay? Sometimes maths gets a bit more complicated and you are likely to get slightly more complex expressions. And for us to segment them well, we use brackets, okay? But sometimes when you are solving a problem in maths, especially the kind that require different steps, a multi-step, a kind that require different steps to solve, you see that sometimes you have to do away with the brackets in the question. And the skill in algebra that you need to remove brackets from an expression is what we call expansion. So that is what we are doing in this lesson. So let me give you an example. You could be given 3 into bracket s plus 5, and then you'll be asked to expand this expression. Okay, because sometimes you are solving a big math problem and you go through the steps and you come to a point like this and you really can't continue until you remove the brackets, because maybe the question demands that we find something that can only be found after the brackets have been removed. So at this point, you need to apply your skills in algebra, and specifically your skills in expanding expressions in algebra. So how does expansion work? It's a very simple procedure. Anything directly sitting outside the bracket has effect on the individual terms in the bracket. Okay, so now the terminology is becoming useful. What is a term? What is an expression? The whole thing is an expression. The whole thing is an expression. But within the expression, there are individual terms. Remember that when we were looking at the hierarchy in the terminology of algebra, a constant and a variable becomes a term, and a term becomes an expression. So here, this one on its own is a term, and this one on its own is a term. Remember, a term can simply be a variable like this s, or a term can simply be a constant like this 5. Now, when they are joined by plus or minus, it becomes an expression. Okay, so all what I'm saying is that for us to understand expansion very well and do it correctly every time, any term or constant or variable sitting outside a bracket has effect on all the individual terms that are within the bracket. And what I mean is that this 3 is multiplying everything in the bracket. So it is multiplying the x on its own, and this same 3 is multiplying the 5 on its own. So if we need to expand this expression and do away with the brackets, we are going to get 3 times s, which is 3s, and then 3 times plus 5, which is plus 15. So that becomes the expanded expression. Okay, when we expand 3 into bracket s plus 5, we end up getting 3s plus 15. It's the same expression. Okay, in terms of magnitude, nothing has changed. Its quantity have not changed. All what has changed is that we have removed the bracket. But because we have removed the bracket, you see that something has happened to the term. For instance, in the original expression, there was a 3, there was an s, and there was a 15. After we have expanded to move the bracket, we have 3x. Okay, and then we have a 15. But in terms of magnitude, in terms of value, the two are the same. So that is the simple way of conducting an expansion in algebra. Let's look at another example. We will start slowly, and then as we build up, we will also increase the difficulty level. So let's look at another expansion. This time, I have a term that is made of a constant and a variable sitting outside the bracket. So 4y into bracket 6 plus 3y. Okay, so we have this expression and we are meant to expand. So let's go back to the basics. First of all, this whole 4y on its own is a term. Remember, a term can be made of a constant and a variable, but in this case, when a constant is attached to a variable, the constant is now a coefficient. Okay, so the coefficient is 4, the variable is y. Okay, now this one is affecting everything in the bracket individually, so long as they are separated by a plus or a minus. So how do we go about the expansion? One thing that we need to understand in algebra is that when terms multiply, numbers go and multiply number to give the product of the number, and then variables stick together to give the product of the variables multiplying. What do I mean? Let me explain. If I have 4y and this is multiplying 2s in algebra, what I was trying to say is that the numbers 4 and 2 multiply to give the product of the number. So 4 times 2 is 8. And then the variables also multiply by sticking together. So it will be yx. But conventionally in algebra, we try to go in the alphabetical order. So although the y is first and the s is second, I will rewrite the product of y and x in a more matured way by bringing the s first and the y second, because in the alphabetical order, s comes before y. So that becomes sy. So that is the product of this and that. So when we bring this scale to expand this bracket, 4y goes for 6 first, and the 4 multiplies the 6 to become 24, and then the y stays because the y doesn't multiply any other variable, so it stays as it is. It's technically speaking multiplying a 1. And then now the whole 4y goes for the 3y. So again, 4 multiplies 3 to give us a product of plus 12. And then the y goes to multiply y. And in algebra, when a variable multiplies itself, it becomes a square. The power increases by 1, and it keeps increasing. So if y goes to multiply y, we get y squared. If another y comes to multiply the y squared, the power increases by 1, so it now becomes y cubed. So here, the 4 multiplies the 3 to give us 12. The y multiplies the y to give us y squared. So the expanded expression of 4y into bracket 6 plus 3y now becomes 24y plus 3y squared. Okay, so that is expansion. Let's consider one more example, then we can come to the end of this part of the expansion. I'm saying this part of the expansion because there will be another video looking at a more complicated type of expansion. Okay, so let's look at this. How about 2sy sitting outside 4y minus 6s? How about this? So this time we are making it slightly more difficult, but the principles remain the same. All this is a term sitting outside the bracket, and because of that, all this is going to affect all of that as a term on its own, and then this one is also going to affect that as a term on its own. Remember, the minus separate the two terms. So let's go. 2 goes for the 4 to give us the product, which is 8. S doesn't get anything, so S comes as it is. S doesn't get any variable that is like S. So, but Y gets another y and return as y squared. Okay, multiplying y and y gives us y squared. So we are finished with the first part. We go to the second part. Again, the same principle. 2 goes for negative 6 and that returns negative 12. The s goes for the s and that returns s squared, and the y has nothing, so the y remains as it is. So the expanded form of 2sy into bracket 4y minus 6x now becomes 8sy squared minus 12s squared y, and that is the expression we get when we attempt to remove the brackets from the expression. which is all what expansion in algebra seeks to achieve. So here ends the first part of our subtopic expansion. Now, there is another video coming up that looks into a more detailed kind of expansion, and that one we call it binomial expansion. Binomial expansion. Now, all along we have kept it simple. So we usually have one term multiplying an expression in a bracket. But what if we come to a point where we are looking at one expression made of multiple terms, 3x plus 2y. Okay, now also multiplying another set of expression something like this. How do we go about this? This is an example of a binomial expansion, and we will be looking at that in another video. So stay tuned and look out for the video that looks at the more complex form of expansions so that you can consolidate your knowledge on expansions in algebra and subsequently use it to solve any problem that you may find in your secondary school or high school math journey. Thank you very much. Have a wonderful day and see you again soon. Bye.